Good morning. We just dedicated the Corkin Center. Very exciting. I'm about to eat my sugar cookie that for some reason has a ribbon on it. But I want to take a minute to talk about a lab that we are going to be starting tomorrow and finishing on Friday. It is called Terminal Velocity Lab. We were originally going to do the buggy lab, but yesterday Miss McCaffrey came and told us that because there's going to be all kinds of visitors on campus the next couple days, and they're doing the Birch Street Bash on Friday, that we're not allowed to make the school messy looking, and the buggy lab does involve putting tape down on the ground in the hallways, and just kind of you guys laying around in the hallways doing a bunch of stuff. So we're going to save that for next week. So terminal velocity. The idea of terminal velocity is that any object that gets dropped eventually will stop accelerating, which means it'll stop speeding up and reach kind of a final speed of its free fall. So I want to just quickly show you how we are going to set that up. You will have instructions for that tomorrow about how we go about that. We're also going to do a tour of the Corkin Center tomorrow, which should be fun. So it'll be kind of half and half lab and doing a tour. So you will need the motion detector. I was able to fix a couple of them, so we should have 6 operational ones as of right now. I mailed 2 more off to the company to hopefully get those fixed for us. You need basically what I'm just going to call a ring stand bolt. Essentially what this does is you can tighten this onto the ring stand, and then there is a threaded screw there on the end that you're going to be able to actually put into the motion detector. So you'll notice the thread inside of there. So let's just go ahead and pop that on. So you will attach that like so. And then this part can be a little bit delicate to figure out. It probably helps to unplug this before you start screwing on there. Let's see if we get a little better vantage point for the camera. Okay, so we are now screwing that on there. Okay, and you don't need to tighten all the way. What you're looking for is tight enough that it's not going to be moving around on you. And then you want to basically make this parallel with the floor or perpendicular with the wall, basically so it's kind of flat like this. And then this will be hanging over the side of your table. Now you need some objects to drop. We've got some old textbooks here that were used maybe at least a decade ago at Grayland, and they're still sitting in our cupboards. So the idea is you need to start the motion detector, and then you are going to drop the book. What the motion detector should do is should kind of detect how that book drops and see what's happening to its speed as it is dropping. Same thing happens with another object, the coffee filter. So you will put this over here, and you will start your motion detector and then drop it. It doesn't need to be an instantaneous thing that you start it right away and then drop it, because you can kind of pick the area of your graph that you will analyze to figure out how fast it dropped. What you want to be considering when you're looking at these motion graphs is what is the shape of the graph? What does a straight line versus a curved line mean? What does it mean to be steep versus shallow? And then we will actually talk about more probably in the beginning of the day Friday, how can we actually calculate the speed from one of these graphs? Friday you'll have an opportunity to maybe test the terminal velocity of a few other objects as well. This is a pretty simple setup. I just wanted to show you how that is getting set up. Good thing to do also is to measure the distance of your motion detector from the floor, so that on Thursday and Friday you can be consistent with that measurement. There isn't really too much more to say. Like I said, the lab handout will give you more details about what you're actually analyzing on there and how to do that, but I just wanted to give you an idea of how to set this up so I don't have to demonstrate this tomorrow. That's it for your homework. See you tomorrow.